All right, so the last part of section number 1, we're going to be adding and subtracting and multiplying with radicals. So if you had 3x plus 2x, you would say 5x. We've done that like before. Radicals are like the same thing. So if you had 3 square root of 7 plus 2 square root of 7, you get 5 square root of 7. So as long as they have the same number under the radical, you may add or subtract them together. If they have different ones, it's like an x and a y. You can't add an x and a y together. Okay? So, a couple problems I'm sure are going to be just like that. So if you had 2 radical 3 plus 4 radical 2 minus 5 radical 3, these are the like terms that you can combine together. So you could just write 4 radical 2 in the front. There's another radical 2. And then you're just doing the numbers in the front. 2 minus 5 is negative 3 square root of 3. So some of them might work like this top one, where you just have one term at the end. Some you might have two terms. That's fine. Okay. But then some of them, you're going to have to simplify the radical. So if we had something like that, you'd look at it and go, well, I can't do anything. Or maybe if you had something like that, you might think, okay, well, those are my like terms, and so I have 4 minus 2 is 2 radical 5, and then just like radical 20. But the 20 we can simplify. And so on all of them that can simplify, we need to do that. And usually if the numbers are a little bit bigger, they're bigger than 10, technically 8 can be simplified, but bigger than 10, you got to look at them to see, can I simplify? So I think, again, I said it before, numbers that are less than 50, I think the best way to do it is just to say what times what is 20, okay, 10 times 2, 4 times 5, okay, but one of them has to have a square root, so I need to choose 4 times 5, because I break this apart, and then, I can do the square root of 4, which is 2. Okay, and then now I can finally, at the very end, combine them together. So any of those numbers that are a little bit bigger, you're going to have to look at. Okay? So just looking at the numbers you're going to have, most of them are okay. 54 is the biggest number, but anything bigger than like 50, we just do what times what is 54, and actually 9 times 6 is 54, and 9 has a square root, so that kind of like works out good. Okay, so you're going to have to simplify some of them in the middle of the of the problem, and then you'll be able to combine it with something else. They're not going to give you a problem where there's nothing to do. Okay, so if you look at, like, some of them at the very beginning, they don't have anything that can combine. Well, that means that at least one of the numbers under the radical, you have to simplify it, and then you'll be able to add or subtract them together. Okay? All right, so multiplying with radicals, I think I've said this before, but you can multiplies numbers not under the radical, and you can multiply numbers that are under the radical, just not one that's not under and one that is under. Okay, so if you had, just to be very like simple, square root of 5 and square root of 2, because they're both underneath, I can make it square root of 10. If I had 5 and I had square root of 2, I cannot multiply that, and it would just be like next to each other like that. Okay, so if they're both just out, they're not under the square root, then you can multiply them together like normal. Okay, so, and the big thing too is I would always simplify first, no matter what. Okay, so what do I mean by that? So if I had something like that. Okay, well, I can distribute. And if I did that, I would get the square root of 96. And then I'd have to see, how to simplify the 96. Okay, or if I simplify first, okay, and so 48's kind of a different number. I said less than 50, just do what times what is 48, but this isn't like an easy one if you don't know it like already. So remember, I'm going to break down numbers, and as soon as I can't break down a number, I'm going to put a box around it just so it stands out. Okay, and so then I want to look for pairs. So I have a pair of 2's, so I write a 2. I have another pair of 2's, so I write another 2, and then I have a 3 that's left over. Okay, so I would much rather change it to 4 square root of 3, because then now distribute, and I get square root of 10, and the square root of 2 just goes with the 3 part, so I get 4 square root of 6. Okay, if not, you'd have to break down the 96, and you can do it. It's not like super difficult. It's just easier, I think, to do 48 instead of 96. Okay, so I would always simplify whenever possible. Okay, kind of glancing at some of the problems here. So if we had something like that. So remember, this means 2 square root of 3 plus the square root of 54, and another 2 square root of 3 plus square root of 54. Okay, but again, I'm going to simplify that 54 first, because I don't want to end up having to multiply 54 times 54, and I'm going to get this huge number that's going to be problematic to work with. So 54 you can actually, it's going to break apart to be, oops, 9 times 6, so, and then if you broke it down like all the way, okay, pair of 3s, so I write a 3. I have a 3 and a 2 left over, so I multiply them underneath. Okay, so over here I go 3 square root of 6 and 3 square root of 6. All right, so now I'm going to distribute. Okay, I can multiply the numbers that aren't under a radical. 2 times 2 is 4. And I can multiply the numbers underneath the radical. Okay, then do the other one. 6. 2 times 3 is 6. 3 times 6 is 18. Okay, and then I'm going to get another 3 times 2 is 6, and another 18. And then 3 times 3 is 9. 6 times 6 is 36. Okay, so a couple things here. Number one, I can do the square root of 9, which is 3. Okay, so I get 12. I can combine these two in the middle. Okay, 6 plus 6, 12, square root of 18. And then again on this last one, I can do the square root of 36, which is 6. Okay, and that gives me a 54. And this one's kind of a hard one. I can add those two numbers together, 54 and 12. That's not the hard part. That's going to give me 66. The difficult part or the hard part or whatever you want to call it, always ask yourself, can I simplify the radical? Can I simplify the radical? I can simplify that 18. Okay, because the square root of 18 is 9 times 2, which is 3 square root of 2. Okay, the square root of 9 is 3. So this really becomes 12 times 3 square root of 2, which is 36 square root of 2. So these like binomial times a binomial ones, depending on the number, you can get some fairly like challenging like steps to go through as you work your way down. But I would simplify underneath the or inside the parentheses like first all the time, because you might get lucky and you might be able to like add some stuff together. So like if I had something like that, you know, you might look, okay, square root of 5 times 2 square root of 3, square root of 5 times square root of 10, you know, and you distribute the whole thing out. But again, the square root of 20, I can write as the square root of 4 and the square root of 5, or 2 square root of 5. So if I have square root of 5 and 2 square root of 5, well, I can add these two things together. And it just makes the distributing part a little bit easier. So when I do that, I get 6 square root of 15. And when I do that, I get 3 square root of 50. Okay, 5 times 10 is 50. So 15, can I break that apart? It's just 5 times 3, so that doesn't help me. But the 50, if I break that apart, I end up with a pair of 5s. Okay. So I get 5 square root of 2. Okay, so 5 square root of 2 or 15 square root of 2. Okay, so it's still not like a super fast, like quick problem, but it's much faster than when you go all the way to the top and you do the square root of 20 and you simplify it. By combining those two things together, I've actually shortened the problem quite a bit, even though I still had to do this other stuff. Okay? So you'll have 6 problems like this multiplying part, and you'll have, I think, 6 problems on the adding and subtracting part. Okay? All right. Have a great day, guys. We'll see you tomorrow.